Let's take a look at example 1. In example 1, we see we have parallelogram CDEF, and therefore all the properties that we just reviewed apply to this parallelogram. So let's label our given information. DE is 74, DG, that's this segment right here, is 31, and we know FCD, or in other words angle C, is equal to 42 degrees. Alright, now we're asked to find CF. Well, CF is this side that is across from side DE. Well, we know opposite sides are congruent and parallel, so CF must also be 74. Now let's take a look at EFC. That's this angle down here at F. Well, F is an angle that's consecutive to angle C. So I know angle C plus angle F must add up to equal 180 degrees. Therefore, angle C, which is 42, plus angle F add up to equal 180. So if I take 42 away from 180, I'll end up with 138 degrees. So angle EFC is 138. Now we are asked to find DF. Well, the length of DF is the entire diagonal from D to F. Well, we know that the diagonals bisect each other, so if DG is 31, GF must be 31, and together D to F must be equal to 62. In our next example, we have a parallelogram PQRS, and again, all of the properties of a parallelogram apply. We're asked to find the length of PQ. Well, PQ is a side here of this parallelogram, and we know the side opposite PQ is SR, and therefore these two should be equal to each other. So I can write the expression x plus 3 is equal to 2x. Now I can find my value of x by subtracting x here, and I'm left with 3 is equal to x. Once I get the value of x, I can substitute that back in for x, and I find out that PQ is 2 times 3, or 6. Next, I'm asked to find the measure of angle R. The measure of angle R is down here in this lower right-hand corner, and I see that I'm also given the measure of angle S. Well, S and R are not opposite angles, making them congruent, but rather they're consecutive angles, making them supplementary. So I know angle S, which is 10n, plus angle R, which is 8n, must add up to equal 180 degrees. And therefore that's 18n equals 180, and n has a value of 10. Now I can take that value 10 and substitute it back in here for my expression, and R is 8 times 10, or in other words, 80 degrees. Now I'm also asked to find the measure of angle Q. Well, I don't have an expression here for Q, but I know that it's consecutive to angle R, and it's opposite angle S. So if it's opposite angle S, it must be congruent to angle S, making it equal to 10 times 10, which is 100. And because it's consecutive to angle R, it should be supplementary to angle R. And you can see that 180 add up to equal 180. Alright, our final example asks us to make a proof that triangle AEB, that's this triangle here in blue, is going to be congruent to triangle CED, which is my other blue triangle facing it. Alright, we know that ABCD is a parallelogram, and therefore all of the properties apply. So let's start by listing our given. Next, we want to use the idea that our diagonals bisect each other. So I know that AC is being bisected by BD, therefore creating this AE segment equal to EC, and this red segment here, BE, congruent to ED. So I'm going to state BE is congruent to ED, and I'm going to state that AE is congruent to EC. And this is because of the fact that as a parallelogram, we know the diagonals bisect each other. Alright, my next statement now is to state that these angles right in here in blue are congruent to each other because of vertical angles. So I'm going to name them angle 1 and angle 2. So I'll say angle 1 is congruent to angle 2 by the vertical angle theorem. And now I have enough to prove that these two triangles are congruent to each other by side, angle, side. So my final statement is to say triangle AEB is congruent to triangle CED by the side, angle, side triangle congruency theorem.